The final hypothesis test that we're going to look at this semester is something called an Ftest, otherwise known as something called one-way ANOVA. ANOVA stands for analysis of variance. So if you ever hear that term again, it just means that what you're really doing is you're looking for the disparity in more than two groups. So when will we use an Ftest? Well, before, when we were looking at a chi-square test, we were looking at a difference in multiple proportions of multinomial events. With an Ftest, we're still looking at multinomial events. But instead of looking at proportions, now we're looking at the means of multinomial events. So for instance, is the average amount of money in Major League Baseball that a shortstop makes is different than the average amount of money that a second baseman makes is different than the average amount of money that a first baseman makes. Those are all sorts of things to where we're testing out the average number, not a proportion instead of what the chi-square test does. The null assumes that there's no significant difference in the means of the multivariate groups. Okay, so there is no significant difference in the means of the groups. And of course, the alternative would be that there is a significant difference. So there is a significant difference in the means of the groups. All right. Now, the variables that we're going to have to collect are a lot. All right, so if you're looking at the formulas that we have just above what I wrote, the null and the alternative, you'll notice that there's a lot of them. Okay, so let's identify what these variables are first of all. So first of all, we're going to have N1, N2, N3, etc. That's the sample size of each group. All right, so if we had 4 shortstops, 5 second basemen, 3 first basemen, the respective sample sizes would be 5, 4, 3. And then the next thing we're going to do is we're going to get N. Now N is the total sample size, and that's basically just found by adding up all the N1, N2, and N3s. Then we have this T1, and we have T2, and then we have T3. Now T1, T2, T3, etc. are going to be the sums of each of the categories, the sums of each of the elements. So we call those the total of the elements or the observations in the categories. Okay. And then of course we have a total of the totals, and we're going to call that the sum of X. So sum of X is the sum of all observations. All right, the other variables we need K, and very similar to the chi-square test, K is the number of categories. And then finally we need the F statistic, and I'm going to talk about the F statistic in a moment, but it's going to be a little bit different than what we've been accustomed to. Just because we're going to be using an F distribution. So let me let you look at the F distribution really quickly. Now the F distribution looks like the chi distribution. The range of values is from 0 to infinity. The cutoff point between the fail to reject and the reject region is going to be this value F critical. Now F critical is a little bit different than any other test statistic or critical statistic that we've seen yet in the course, because it's going to be based on 3 values, not 2. Usually it's degrees of freedom and alpha. So for F critical, you need alpha. You also need degrees of freedom in the numerator. All right, and we have a formula for that. Degrees of freedom in the numerator is going to be K minus 1. So that's not too difficult to compute. And then you need degrees of freedom in the denominator. That's going to be equal to N minus K. All right, so you're just going to compute those. And then what you're going to do is you're going to look at the F table. Now the F table was different than the other tables because each page is a significance level. All right, so what you're going to do is you're going to look at the F distribution, and what you're going to notice is that on each page there's a significance level. So the first thing you want to do is you want to identify what significance level you're looking at. Okay, so there's 4 pages because there's going to be 4 possible significance levels. And then the degrees of freedom in the numerator are going to be each of the rows. The degrees of freedom in the denominator are going to be each of the columns. Okay, so the table's a little bit more difficult than the other tables to use, although it's still not too difficult. All right, to get the test value, you're basically going to use 5 steps. The test value is going to be computed first by computing this thing called SSB. All right, SSB stands for sum of squares between. It doesn't really matter. It just matters that you know how to compute it. Then you're going to compute this thing called SSW, sum of squares within. Then you're going to compute mean squares between, mean squares within, and then finally you're going to get the F statistic. All right, and that's going to be our test value. When we do a couple examples of this, I'll show you the specific mechanics behind this. All right. Unfortunately, SSW is going to be the most tedious to compute. All right. I'll show you again how to do that in a few moments. All right. Then the conclusion, you're going to plot the test value on the distribution, just like we've done a number of times. And then if the test value falls in the reject region, we reject the null. That means that there's enough evidence to suggest that there is a significant difference in the means for each category. Right. So in the next 2 videos, what we're going to do is we're just going to look at a couple examples of being able to go through the steps of being able to evaluate one of these types of hypothesis tests using one-way ANOVA.